A new collaboration makes Arduino IoT projects more secure. Even if you don't have a quantum computer, you can still start with TensorFlow Q. PCBite can be a great help for your production workflow. We have an interview with Peter Michielsen about developing processors in Europe, and and Aha found a clever way how not to touch your face. Welcome to the IoT Radar. Arduino, Thales, Telstra and Microsoft team up to pave the way for a scalable security solution for IoT devices. The solution enables authentication between a device and the cloud platform via cellular networks. As soon as an IoT device is switched on, any SIM or eSIM featuring Thales IoT Safe application is automatically and securely provisioned. Once the IoT device gets a proper digital certificate, created and stored in the SIM, a trusted communication between the device and the server is permitted. TensorFlow goes quantum. If you want your machine to learn something, you use TensorFlow. This open source machine learning platform can be installed on many different hardware platforms like a Raspberry Pi or a quantum computer. You don't have a quantum computer, no worries. Last week, Google announced TensorFlow Quantum, and TFQ is a collaboration between the University of Waterloo and Volkswagen. It provides an open source library for rapid prototyping of quantum machine learning models, bringing computer and machine learning research communities together. Great. In one of the coming IoT radars, I hope we will have a background around this subject. When you develop a PCB board, you need to solder, measure, inspect, modify, and the board will go from one person to another, from desk to desk, not always very effective. PCBite is a set of tools helping you to get your PCB design through all these essential development phases. And I'm here with Magnus. Magnus can tell what exactly is biting.
Yeah, well, biting, it's a system for a solution actually for holding and handling a circuit board through the whole developing phase in a company. We start out with actually holding the circuit board, securing it through the whole development chain. So then we decided to add some measurement probes to make it easier to hands-free measurement.
Yeah.
So
can you show? We have some demos here.
The problems we run into was the circuit board holders we saw in the company we were working only had like stationary.
Yeah.
So it didn't follow the flow we had for the development. So if the hardware engineer does some soldering and pass it, he would like to pass it forward to the next guy doing the software solution and for the testing. So if we need to tear everything down, put it up again, it took a lot of time. So it didn't reflect the way we were working. So we decided to make this solution. We have the base, we started with these holders. Yeah. Everything is easy to use, of course. So you secure the circuit board, you can do a lot soldering, pass it forward to the next one, doing the measurement. So, and everything is, of course, the user friendliness is a thing we think about a lot.
It's great, yeah.
So these probes are flexible, sturdy, just push, release, and stay in place.
Okay.
So it reflects the way we are working, not the opposite around.
This week, the European Processor Initiative conference in Paris was cancelled due to the coronavirus. Nevertheless, the initiative will go on, and I have a Skype conversation with Peter Michielsen from Surf about developing high-performance computer systems in Europe. Surf is a Dutch organization bringing together high-performance IT solutions for public-funded research. Good morning, Peter.
Good morning, Wis. Hope you're fine.
Yeah, I'm doing fine, thank you. Europe wants to develop its own processor. What is this?
Well, that is the European Processor Initiative, which is basically funded by the European Commission. And the actual idea is to make sure that Europe will have access to processor technology independent from the US and China and Japan. So it's a large endeavor to make sure that we, in the end, can bring our own CPU, our own GPUs to make sure that we have access to HPC systems which are competitive to China, the US, Japan. So independence for Europe in that respect.
Why is it so important to have this technology also in Europe? Is it a matter of trust, or is it a matter of having access to this technology?
So in one way, it is making sure that the European economy is able to do this themselves. And on the other hand, is to make sure that if there becomes a time that the situation becomes difficult in the world, that Europe has its own initiative, has its own facilities, for instance, to, well, let's say, to simulate calamities like we have right now. It also gives Europe a platform to develop its own science, to make its own choices, and be not dependent of foreign technology.
Do we have the technology for this in Europe? Are we up level with what is happening in the US or in China? Or do we need to speed up a bit, more money, more research?
Well, that's a good question, of course, because if you start such a project, then you cannot do it for a few years. You have to do it, let's say, a very long time. You have to do it for decades, because otherwise the investments you are doing right now do not make any sense. European Commission puts in a lot of money, but also the member states are asked, and also industry, to put in their money to make it a common goal.
Yeah. Now, you hear that one of the technologies, or one of the architectures that might be a good candidate for a new processor is RISC-V. The first question, of course, is why is the RISC architecture in such a good position for high-performance computer systems?
But what you can see is that, for instance, the ARM architecture is an open architecture. It has been started in Europe some time ago, you know where it is right now. This kind of architecture is being meant as a low-power processor technology. And the actual idea of the European Processor Initiative is to have on one side a processor which is suited for simulation, for high-performance computing, simulations and all that kind of stuff. But on the other hand, there should also be something which can be used in a low-power mode for instance, for electric vehicles or autonomous driving and that kind of stuff. So that is basically, the EPI focuses on two roads. First is the real high end, but in the volume sense, it is also the low power variant, which can be used in, well, other kind of technology.
Yeah.